Hello friends, welcome to the new video of the Nukkadcode, and in this video we are going to learn about a very important concept, that is memory model. And let me tell you that we are not going to learn about a whole Java memory model, but we are going to learn about two important memory areas that are very important to understand, and each developer must know and understand about them. We are going to learn about the two major important memory areas where the variables are created, where are instance variables created, where are new objects created, and where are local variables created. So let us understand about these in a very interesting way. We are going to learn about two important memory areas, and here is one. You can see here it is stack, and you can see the other one, that is heap area. Okay, first of all let me write here the headline, that is we are going to learn about two major memory areas, that is stack and heap. So let me write it here, memory area, important memory areas. One is stack, this is one is stack, and another is heap. So this is stack and this is heap. So let us see about the stack here. What happens and how stacks are formed. What is stack? So stack is basically a collection which is based on the last in first out manner. That is last in first out principle. Okay, so stack is a collection which is based on the last in first out principle. And what does this mean, last in first out? So let me tell you about the last in first out. Let me write it, it's a full form, like last in first out. Last in first out. What does this mean? Let me show you with an example. Here you can see I have 6 plates. I have some plates here. So when I start creating a stack, so suppose this is my hand and this is just empty stack. I have this stack is empty. So first of all I put the first plate. So on this stack I put the first plate. So first plate comes here. After that I put another plate, that is second plate, and you can notice that this is on the top of this. Then this, then another one, then another one. You can notice that my first plate is at the bottom and the next other plates are coming on the top. So whenever I put a bottom is here. Whenever I put a plate, new plate, I am putting always the new plate, this new plate always on the top. Okay, because I only have this option. So now you can see it is a stack of plate, and when I have to take this plate out, then first what I have to do, I have only the option to put the plate which is on the top and get it off from this. So first of all, when I am going to remove this plate, then I have to capture this plate, and then I will able to remove. That is, whenever I want to remove, I always have to remove from the top. So you can see, that is, what does this last in first out means? Means last in first out. That is the last, which was the last plate which I which I kept on this stack, the plate of stack of the plate. This was the last plate which I kept on the stack. Now last in, this is the last in plate, and first out. Whenever I have to remove from this stack of plate, I have to remove the first plate which was last in. So our last in plate is going to be out first. So this is called as last in first out. I think you got the concept of last in first out. What is last in first out? Okay. So now what is the it is what the stack is going to do with our case. So now let's understand what stack is going to do in our case, that is where the instance variable, the local variables and the new objects are created, whether they are created or stored on stack or on heap. So let's understand that thing. So friends, think about what happens when we create a new instance variable, int variable, new object, parameters. Then where these go, that is where they are stored in the heap area or they are stored in the stack area. So let us understand in detail about this. So suppose we have a Java application, class A and public class A, and inside it public class A, and inside it we are going to have a main method, that is public static void main string x, and then curly braces for the main method open and curly braces for the main method is closed here. And inside it, suppose we are going to have a int variable, that is int I is equal to 10. Okay. Now let us understand what happens when compiler compiles, and then when we run this application. When we run this application, then what is going to happen? So friends, here is our example, simple example with the main method. So here is our class, and in this class we are having only one method, that is main method. So it is main method. So in this class there is only one method. Okay. So while running this application, what happens at this line, that is public static void main, what happens? A new stack frame for this method, that is main method, is created. So what is stack frame? Let us understand about the stack frame. Okay friends, now let us see this example in detail. So here we have our class, and inside it we have a method, only one method, and that method is main method. Okay. So what happens at this line? At this line in memory, what happens in the stack memory? Here you can see in this stack memory a stack frame is generated. So let me write the term stack frame. Stack frame is generated. Okay. And what is stack frame? Stack frame is basically, you can say that stack frame is a container which contains the name of the method and the variables inside it. Okay. So this is stack frame. So now let us see, in this stack we have a stack frame that is created for this main method. Okay. So here you can see we have, this is a stack frame for main method. Okay. So always remember what happens when a method at this line, what happens? A stack frame for the main method is created. So here you can see stack frame for the main method is created, and inside it what will be? Inside it should be an int variable I, and its value should be 10. So here let us open this and let us see how the stack frame contains the values, that is variables. Okay. So here is our stack frame for main method, and inside it we have int variable I. So here you can see we have int variable I, and at this line let me tell you, that is int I. When we write int I, we simply have a primitive variable I. So this is our primitive variable I. Okay. And where this I lies? This lies in the stack frame of the main method. Now when we assign this value to 10, that is I to 10, what happens? Means this I is now containing the value 10, the primitive value 10. So inside it, here I am having the 10 matchsticks. So a point to remember here, that this local variable, this method, since this variable is declared inside a method, that is a main method, so it is a local variable. Okay, it is a local variable. So local variables are stored in stack frames. Local variables stored in stack frames of the method. Frames of the method, that is corresponding method. Okay, now suppose what happens if we are having a reference here for an object. Suppose we have a reference for mobile m equals new mobile. Okay, so what will happen at this line, and how and where these things are stored in the memory, that is whether this m, that is mobile m, the m reference which is containing the object new mobile is going to store. Okay, so here when we write new mobile, always a new object is created in the heap area. So a new object will be created in the heap area. So here you can see we have our heap area, and inside it a mobile object is created. Okay, now inside it a mobile object is created. So here is our heap area, and mobile object is created inside the heap area. And where this mobile m, this reference is created, where this is created, is it created in the heap area or stack area? So let us discuss about it, where this is created.